Okay, this should actually be Module 12. I had a typo there. What transformations could result in a similar figure that is a reduction or an enlargement? There's 3 of them. Can you think of what they are? A compression would be one. What is the opposite of being compressed? Being dilated. Dilation would be another. And finally, there's one that we see in graphs as a transformation on a graph, and we call that a stretch. So those are the 3 transformations that will result in a figure that is not the same size. Those are your non-rigid motions. So how deep is that water there? What do we have to look for? Well, we've got to match our pieces up. If I am looking at that smaller triangle only, it is 5/12. Okay, so now, the biggest mistake I will see is that they will want to use the 25 instead of the whole thing. So the whole thing is 5 plus 25 over D. Make sure you're using that whole side. So 5/12 is equal to 30 over D. Do your cross multiplication. 30 times 12 divided by 5. 30 times 12 divided by 5 is equal to 72. So the distance across is about 72, and this would be meters. Okay, so if you're looking at this, you're told that the triangles are similar. I also could have done arrows here to show that you've got those parallel lines. So what is the length of SB? SB is this little piece here. There's 2 ways we can find it. We can either go from top to bottom or from side to side. But I want you to look, and I want you to look at the bottom here. The bigger piece is 18, the smaller piece is 6. What is their relationship? If you said that 6 times 3 gives me 18, it tells you what you need to apply here to find that other piece. So if you did not see it, SB over 7 is equal to, SB is on the top, 18 over 6. Okay, is that the only way you can do it? No. I can go side to side. SB over 18 is equal to 7 over 6. Either way, you start by taking 7 times 18 divided by 6. 18 divided by 6 is 3. 7 times 3 is 21. So SB will be equal to 21. Okay, to find ST. ST is this long piece here. If you're looking, the two bases are 9 and ST. 9 over ST. 9 is on that smaller triangle. Now I'm going to use the bottom numbers. So this is 6. And then the whole thing, because we're looking at the bigger triangle, the whole thing is 18 plus 6. Is that the only way to do it? No. I could have gone 6 over 9 equals 18 plus 6 over ST. Both are the same. You start by taking 9 and multiplying it by 18 plus 6. 18 plus 6 is 24. Divided by 6. Okay, now if I didn't want to do any of the math in my head at all, 9 times parenthesis 18 plus 6 parenthesis divided by 6. 36 is my answer. Could I have used the other side? Yeah, I could have had 7 over 21 plus 7. But the important thing to remember is you've got to have that whole side, that whole length, which means you have to add the two pieces together. Okay, so as we're looking at the next one, if they're congruent, what do we know about their angle measures? They're going to be if they're similar, what do we know about the angle measures? They're going to be congruent. So this is 110, this one's 35. How do I find the measure of angle Q? Well, altogether they're 180 degrees. We're going to subtract 110 degrees plus 35 degrees. Measure of angle Q is equal to 180 degrees minus 145 degrees. 180 minus 145 gives me 35. So this is 35 degrees. What about the measure of angle B? Well, the measure of angle B is in the middle, L is in the middle. So angle B and angle L are congruent. Which means that it will be 35 degrees for both of them. Any questions? Okay, for the similarity statement, we know that these will match up. So triangle, SUT, is similar to triangle. 39 matches 13, so it's going to be EUD. Okay, so how do I find X? Well, I have to put my numbers together. So I've got 13 over, these two go together, x minus 2 is equal to 39 over x plus 9. This time I have to do that cross multiplication. Thirteen times x plus 9 is equal to 39 times x minus 2. Can I make my life any easier right now? Yeah, I can by simply dividing both sides by 13. I end up with x plus 9 is equal to 3 times x minus 2. Now, I still have to distribute before I can solve. X plus 9 is equal to 3x minus 6. I'm going to subtract subtract x from both sides. 9 is equal to 2x minus 6. Add 6 to both sides. 15 is equal to 2x. And finally, we divide by 2. 15 halves is equal to x. 15 halves is also 7.5. I'm going to actually use the decimal. Okay, so for ST, ST is x plus 9. Okay, so ST is equal to 7.5 plus 9, which is equal to 16 and a half, or 16.5. What about DE? Okay, if we look up here, DE is x minus 2. So DE is equal to 7.5 minus 2, which is equal to 5.5. Remember, in the real world, things get messy. Not everything is a nice whole number. I know that if I had to round, I'd have to round down on my height, and that would make me shorter. But I'm not exactly 5 feet tall. I'm a little bit over that. And I'm glad I've got that little piece that's over 5 feet tall. Okay, a telephone booth that is 8 foot tall casts a shadow that's 4 foot long. Find the height of a lawn ornament that casts a 2 foot shadow. What is the scale factor of the telephone booth to the lawn ornament? Okay, so as we're looking at this, we're given several things. The booth is 8 foot and it has a shadow that's 4 foot. The shadow of the lawn ornament is 2 foot. And we want the scale factor from the telephone booth to the lawn ornament. So if we're looking at it, the first thing to do a lot of times is to draw the diagram. The diagram will help you see what is going on. So if I've got my telephone booth here, it is 8 foot tall, and its shadow is 4 foot. If you're looking at that, you can see a definite relationship between the height and the length of the shadow. If you're looking at the lawn ornament, I don't know how to make a lawn ornament, so I'm just going to make a ball. We're looking for the height. We know that the shadow is 2 foot. What is the relationship between 4 and 8? Well, 4 times 8 is 2, so I know I'll have to use that same relationship down here. 4 times 2 is 8. 4 times 2 is 8. The same relationship will hold down here. 4 is 1/2 of 8, so 2 will be 1/2 of this number. Okay, to find the scale factor. The scale factor times 4 will give me 2. Because the 4 and the 2 are in the same spot. When I divide both sides by 4, then my scale factor is 2 divided by 4, which simplifies to 1/2. Okay, but what about that last length? Well, we can multiply 8 by 1/2 and get the length. So this would be 4 foot. Or 4/8 is equal to 2/x. Once again, same thing. 2 times 4 is, or 2 times 8 is 16. 16 divided by 4 is 4. So we are given that they are similar. And you're given the measure of EF is 18, the measure of FG is 22, and the measure of KJ is 36. So we're going to draw the picture. Okay, EF is 18, FG is 22. We know that KJ is 36, and we're looking for JL. Okay, 36 and 18 match up, X and 22 do. So I'm going to go 36 over X is equal to 18 over 22. Or 36 over 18 is equal to X over 22. Either way, you're doing the same thing. You're multiplying 36 times 22 divided by 18. And you end up with 44. Okay. Once again, they are similar. And we're wanting to find X, VT, UV, and SR. So as I'm looking at this, the easiest one for me to find will be SR. I can find it quickly because I know Pythagorean's theorem will work. So, SR squared is equal to 15 squared plus 25 squared. The opposite of squaring is to take the square root. I'm rounding to the nearest tenth. So this will be 29.2. SR is approximately 29.2. So SR is approximately 29.2. Okay, so now we can set up the equivalent fractions, the proportions, or we can actually use these numbers to figure out x. But so let's set up that proportion. If we're looking at corresponding parts of the triangle, we've got 70 over 5x plus 2. And that will be equal to, your long side is 70, the long side here is 25, over the short side, which is 15. So I'm going to do all the multiplication at one time. I'm going to take 70 times 15 divided by 25. And I end up with 42. 5x plus 2 is equal to 42. So I know that this length is 42. To solve for x, I subtract 2 from both sides. 5x is equal to 40. And then I divide by 5. X is equal to 8. So I found SR, I've found X, and now I need to find UV. I can use Pythagorean's theorem again for UV. UV squared is equal to 70 squared plus 42 squared. The opposite of squaring is to take that square root, putting it all into the calculator at one time. 70 squared plus, whoops, I forgot to square it. 70 squared plus 42 squared. And we end up with 81.63, which is approximately 81.6. And I am done. So if we're looking at finding x, y, and z, the first one we can find is actually x. This is your geometric mean. So as I set it up, 2 over x, short side over long, short leg over long leg, is equal to the long leg, which is x, over 10. Short leg over long leg is equal to the short leg over long leg of the other triangle. So 2 times 10 is 20, and that's equal to x times x. 20 is equal to x squared. The opposite of squaring is to take that square root. We're rounding to the nearest hundredth this time. So the square root of 20 is approximately 4.47. Now, y and z are both the hypotenuse of our right triangle. So we can easily use Pythagorean theorem to find the missing links. For y squared is equal to 10 squared plus 4.47 squared. Once again, the opposite of squaring is square rooting. Using the calculator, second, x squared, 10 squared plus 4.47 squared, and I get 10.9535. So y is approximately 10.95. Same thing is going to happen for z. We know that z squared is going to be equal to 2 squared plus 4.47 squared. The opposite of squaring is square rooting. Putting it in the calculator all with one step is the square root of 2 squared plus 4.47 squared. I hit enter and I get 4.897, though this is approximately 4 point, we're going out to the nearest hundredths. So the 9 rounds up to 10 and the 8 rounds up to 9, so this is 90. If you put 4.9, you would not be correct because you're rounding to the nearest hundredth. You have to put that 0 there as a placeholder. For the last one, are the triangles similar? If so, state the reason and write the similarity statement. So we're looking at, is it possible that this is side angle side similarity? Take a minute and look. 50 is congruent. So we have one congruent angle. What is the relationship between 12 and 24? What is the relationship between 8 and 16? If you said 12 is half of 24, you would be correct. So I would be looking at 12 over 24. That gives me 1 over 2. I can look at 8 over 16. That gives me 1 over 2 again. They're in the same proportion, so they would be similar by side angle side. Triangle ABC is similar to triangle. Okay, A is my short side, AB is my short side. DF is my short side. So it would be DFE by side angle side.